In this video, we're going to start learning about the sine and cosine functions, the first of 6 trigonometric functions that we'll be dealing with in this course. Sine and cosine are by far the most commonly used trigonometric functions, but the others are just as important, and you will see them from time to time, so it's important to know what they are and how to use them. I'm going to start by drawing a circle. Hopefully it'll be a decent circle. That's not too bad. And I'm going to overlay a set of axes. And this isn't too different from what we've done so far, right? I've set down axes and then I've described an angle based on the initial ray being on the positive x-axis, and then, some rotation around from that. Sometimes the rotation was bigger, sometimes it was smaller, sometimes it was a lot bigger, sometimes it was negative. And that's kind of where we're going to start today, although I'm going to start in quadrant 1. So I'm going to just put let's go ahead and do a pink initial ray. I'm just going to stop there, and I'll put a terminal ray. Let's see, maybe I'll put it about there. Okay, now normally these would extend farther, but I'm going to stop them there because one of the things we want to be looking at in this section is what are the coordinates of this point right here, the point where the terminal ray intersects with this circle. The radius of the circle is the length of the segment between the center of the circle and the circle itself, right? The terminal ray, the part of the terminal ray between those 2 points. That's the radius of the circle. And I'm going to call this angle theta, at least for now. Now, something else that we can do is we can take a look at what the coordinates of this point are. This point right here, we'll call it x comma y for now. Notice that if I drop a vertical line down, some x coordinate here tells me how far in the horizontal direction I have to move in order to get to that point. And if I draw a horizontal line, it will tell me how far I have to go in the vertical direction to get up to the height of that point. So without the circle here, I could just say x comma y, those are the coordinates of that point. But the point of this particular video is that we're going to name these coordinates now. We're going to define the sine and the cosine based on these coordinates. Let's make the observation that the length of this line segment right here is x, and the length of this line segment right here is y. In other words, I have a distance between here and here of x, and between here and here of y, right? So that's the length of that piece of the array, and that's the length of that piece of, well, the height of the height of the coordinates, right? This is the distance out to the length at which the x coordinate occurs. So we're going to define the x coordinate, or the distance here. It's actually the distance we're defining here, but it turns out to be the same, so we can use this equality. The x coordinate here is at a distance from the center of the circle of r cosine theta. And that's just by definition. We say that x, the length of this line segment right here, has a distance, a length of the radius times something we call the cosine of theta. Now there's another way to talk about cosine, and I'll come back to that in just a minute. It's actually a topic for much farther on in this chapter, but I'll address it briefly here because I know some of you have seen it and I don't want you to get confused. Equally, we're going to define the length of this line segment as r, tool there, r times the sine of theta. Now we need to talk about some of this notation, but for right now, that is where we're going to stop, just in terms of what is the definition. So this distance, this length, is defined as being r cosine theta, and this length is defined as being r sine theta. When I say they're defined as, that means that I've just decided to call it that, and it's not just me, it's, again, millennia of mathematicians, but we've just decided to call it that, and we're going to base all the rest of our work on that definition. There are two ways to learn things in mathematics and probably in other disciplines as well. One is by discovering it. For example, if you worked long and hard enough, you could probably discover for yourself that a squared plus b squared equals c squared, right? You could discover that based on your own experimentation. Okay, so there's discovery learning. That's one option. One possibility. Another possibility is definition learning. And definition learning is not something you can figure out for yourself. If you discovered some properties that made you want to name this length and this length, the chances of you coming up with these particular definitions for those two things are very slim indeed. So this is just something you just have to take for granted. This is something that mathematicians have decided and have been working with for millennia, and it just is, right? It's not something you can rename or redefine and be understood. You have to take these definitions and go with it. Now, something else we're going to do, primarily because your textbook does it, and I'm not really sure I've ever really understood why textbooks do this, but we're going to rename theta here, and we're going to call it t. All right, so we have, I'm going to call my angle t, and I'm going to call this r cosine t and r sine t. And it is literally just a renaming of the angle. We're calling it t instead of theta. The other thing I'm going to do here is I'm going to redefine the radius. I'm going to, instead of having this have a radius of r, I'm going to give it a radius of 1. And that means that my r's here are also going to be 1's. And because 1 times the cosine of theta, or 1 times the cosine of t is just the cosine of t, I'm just going to leave it. Cosine of t, sine of t. I don't need the 1. What I have here now is called the unit circle. Right? It's called the unit circle because it has a radius of 1 unit. And that's really all that is. Let's take a moment and recall that we had a formula in the previous section, S equals r theta, which we can now rewrite as S equals RT. And when when R equals 1, when the radius is 1, we have just S equals T. So what that means is that as long as the radius is 1, the arc length out to some point is equal to the measurement of the angle. Now the arc length out to some point is going to be measured in inches or millimeters or miles or something, and the angle is going to be measured in either degrees or radians, but the numerical measurement will be the same. So if my measurement out to this point right here along the arc is, say, 1.3, then the angle is also going to be 1.3, either radians or degrees. Now, which is it? Well, this t, this idea right here that we have, that s equals t, that this arc length equals the angle measurement, comes from this formula. And if you'll recall, in this formula, theta, and therefore in this formula, t, has to be in radians. So if s equals 1.3, then t equals 1.3, but it has to be in radians. I'd also like to make the observation that for a triangle set into the unit circle like this is a right triangle, right? Because I dropped this vertical line down from the point I was interested in down to the x-axis. So that is a right triangle, and therefore this length right here and this length right here, the sides of the right triangle, are x and y respectively. So if I take x squared plus y squared, I'm going to get 1 squared, or 1. But we said that x was going to be defined as r cosine theta, and in the unit circle, that's just cosine theta, not r cosine theta. It is still r cosine theta, but r is 1, right? So we're going to have cosine theta plus y is equal to sine theta, and that's going to be squared, and that's going to be equal to 1. We have some notation that we use in trigonometry in order to avoid having to use these parentheses all the time. You'll often see this, almost always in fact, see this written as, the way this would be read is cosine squared theta plus sine squared theta equals 1. And of course, that could also be cosine squared of t plus sine squared of t equals 1. You might be wondering what happens when the radius is not 1. Well, then you still have an r in place. So there I would have, instead of x equals cosine theta, I would have x equals r cosine theta. I think I'll stick with t here because I want to be consistent with the way your textbook is writing this. Plus, and then for y, I'll have r sine of t, and that's all squared. But that's going to be equal to the radius squared, right? The formula is x squared plus y squared equals r squared. Well, the r, when it's not just 1, when it's r, when it's some unknown radius r, we have r squared. So if I square this now, or if I expand this now, I get r squared cosine squared plus r squared sine squared equals r squared. And if I divide both sides by r squared, I get cosine squared plus sine squared equals 1. So this formula, this piece of information, is going to come back and, I want to say haunt you, but it's not exactly haunting you so much as you're going to see this a lot. Okay, let's take a look at an example of a specific point. This is the unit circle. Didn't do quite such a good job there that time. And I have a point here. Maybe I'll go with the pink again. I have a point there, and I tell you that the coordinates of that point are the square root of 3 over 2, comma, 1/2. Then, first of all, you can verify that that's the case if you know this is the unit circle, because you know that it's going to have a radius of 1. And you'll be able to verify that it's true simply by saying, well, x squared plus y squared still has to equal 1, because the radius of the circle is 1, the hypotenuse of my right triangle is 1. So I can verify this by saying, is it true that the square root of 3 over 2 squared plus 1/2 squared equals 1? Well, this is certainly equal to, those should both be squared, 3 over 4 plus 1 over 4, that's 4 over 4, which is 1. So in fact, it's true that these can be coordinates on the unit circle. Equally, I can say that at this point, at the point with these coordinates, the cosine of t is equal to the square root of 3 over 2. And the sine of t is equal to 1/2. Because for this angle, x is defined as the cosine of t. The cosine of t is the same as the x coordinate. Now you might be asking yourself, well, how do I know that these are the coordinates of that point? And the answer is a little bit complicated, but we're going to be talking about that in the next video. So I'll leave it here for now, and we'll come back and talk about finding the coordinates of special angles around the unit circle in the next video.